A very good morning to all of you. I cordially welcome you all for this engineering thermodynamics course. So today's classroom discussion topic is what are the causes of irreversibility and conditions for reversibility we have to discuss in the today's class. And what is the motivation to study this particular the topics? So it is essential to know that why a reversible process is not possible in the actual practice and why all spontaneous processes leads to an irreversible process. So that we have to study under this particular classroom discussion topic. And every lecture is having its own objective as well as the outcome. So this lecture also having the two outcomes. So I'm expecting after the completion of this lecture, you should be able to identify the causes of irreversibility and analyze the conditions for the reversibility. So before going to study what are the causes for the irreversibility and conditions for the reversibility, so first of all, we have to know what do you mean by the reversible process? And we studied that is the initial state can be restored back after completion of the process along the same path. So if it is taking place according to the same path, then it is called as a reversible process. If the initial state is restored back along the different path, then it is known as the cyclic process. That is the difference between the reversible process as well as the cyclic process. And during this particular the process from the intermediate state to that is the initial state to the final state. So the intermediate states are normally passing through the equilibrium states. So that is whenever you are joining all these equilibrium states by a continuous line, then it is known as a reversible process. And already we discussed that quasi-static process it can be treated as an example of the reversible process because the quasi means it is the almost, static means it is the uniform. So almost uniform process and the deviation from the equilibrium states is infinitely very small in case of the quasi-static process. So that's why the quasi-static process can be treated as an example of the reversible process. And now here we have to study why all the reversible processes will not happen in the actual practice. That is here the first one, the reversible processes actually do not occur in the nature. So what is the reason for it? So that is why all the spontaneous processes are leading to an irreversible processes. So that we have to study in detail. So normally here, why we are interested in the reversible process? If they are not happening in the actual practice, then why we have to study or why we have to analyze the reversible process? So here I have given you some of the reasons here. So the engineers are interested in the reversible processes because when reversible processes are approximated instead of the actual ones, work producing devices such as the car engine and gas or steam turbine deliver the most work, and the work consuming devices such as the compressors, fans and pumps consume the least work. That is here it is very important point you have to remember. So that is always the devices are classified into the two types. One is the work producing devices and the second one is the work consuming devices. So the examples for the work producing devices are here I have quoted, that is the steam turbine, gas turbine and heat engine. So they will produce some amount of the work by taking some amount of the heat input. Whereas the work consuming devices here I have listed down, that is the compressor, is the fan, pumps, blower, refrigerator, air conditioner. So these are the work consuming devices. So now why we are interested in the reversible processes though they are not happened in the actual practice. So just I am giving you one example. So whenever we are going to the road, going onto the road, so we are able to see some of the advertisements are listed. That is, this particular bike will give you some 108 kmph, that is a 108 kilometers per liter. That particular vehicle is a two-wheeler vehicle, and there you are able to see some small three stars, and below which the conditions will apply or under the standard test conditions. So that is a very small letters they will indicate this particular one. But whenever you are running that particular the vehicle, so that will give you only some 60 kilometers maximum or 55 kilometers only. So it is not giving us 100 or 108 kilometers, whatever which is prescribed by the company. So then why we are not going to the court and why you are not putting any case against that particular the company? Why? Because under the ideal conditions, under the standard test conditions only, that will give you that particular 100 kilometers or 108 kilometers which is prescribed by the company. But whenever it is running on the actual road conditions, so actually its performance will be deteriorated and it is giving us only some 50 or 55 or 60 kilometers per liter only. So there is a lot of difference between the standard test conditions and actual test conditions. So that's why if we want to know, so how much maximum mileage which can be expected from that particular the bike or from that particular the car. So car is also, advertisement says that is a 25 kilometers per liter it will give you, but on the actual test conditions it will give you only some 16 or 17 kilometers per liter. So that is, we should know what should be the maximum mileage which we are expecting from that particular the car or from that particular the bike. So that's why the reversible processes are approximated instead of the actual ones. Work producing devices will deliver the most of the work whenever they are running under the ideal test conditions. So we should know the maximum mileage or the maximum efficiency what we are expecting from that particular the devices. So that's why the reversible processes are very important one. And why these are not possible in the actual practice. So why all the spontaneous processes are leading to the irreversible processes? So there are several reasons are there. So just here I have given you some of the reasons. So the first important reason is the friction. So that is, always the friction is there whenever we are doing some amount of the work. That is, if you want to run or if you want to walk, so whatever the work which is to be happened, so always there will be some amount of the friction. So it is the actual conditions, but under the ideal conditions, that is a frictionless process. So that is, they are simulating the frictionless process and they are getting the maximum mileage and maximum efficiency out of that particular the devices. So but in the actual practice you cannot overcome the friction. That is, always you have to consider the friction into the consideration, so due to which the mileage or the efficiency is normally decreases. And the second one is unrestrained expansion. That is, the unrestricted expansion is also one of the reasons, so due to which we are able to get it is the irreversible process. And the mixing of the two gases is also leading to always the irreversible process. So that is, the fourth one is the heat transfer through a finite temperature difference. But normally whenever we are going through the ideal or the simulated conditions, we are assuming that heat transfer through an infinite temperature difference. But it is not possible under the actual conditions. So always we have to consider heat transfer through a finite temperature difference only. So all these are basically leading to the irreversible processes conditions. That is, we cannot avoid the friction and the unrestricted expansion and heat transfer through a finite temperature difference. All these things are basically leading to the irreversible process. So that's why all the spontaneous processes are basically leading to irreversible process, but we are interested in the reversible process because to know the maximum efficiency or the maximum mileage out of a particular device. So that's why the quasi-static process approach we are following, that is, it is slowly that is behaving like the reversible gases conditions. So that's why we are interested in the quasi-static process. And here I have listed down some of the differences between the reversible process and irreversible process. Just you go through the differences. That is, in the reversible process, the first one is the process is carried out infinitesimally very slowly. That is, just now I told you that in the quasi-static process also, that is, it is basically taking place at very slower rate. Exactly reverse is happening in the irreversible process. Here it is carried out very rapidly. And coming to the second one, at any stage the equilibrium is not disturbed. So just now I told you that the reversible process is nothing but it's the locus of all equilibrium states. So that is, we are able to represent it by a continuous line. That is, the continuous line is basically drawn through all the locus of the equilibrium states. So that's why the equilibrium state is not at all disturbed in the reversible process, but whereas in case of the irreversible process, so automatically there will be some disturbances will take place. And it will take the infinite time to complete the process in case of a reversible. So because it is carrying at very slower rates, so automatically the time taking is also normally very high. So, but exactly reverse is happening in the irreversible. And the fourth one in the reversible process is the work obtained in the process is maximum. Absolutely. And exactly in the irreversible process, it is not at all maximum one in the irreversible process. So like that, we can differentiate the reversible process and irreversible process. And as we expected, so at the end of this particular lecture, you should be in a position to mention what are the causes for the irreversibility, why all the spontaneous processes are leading to the irreversible process, and under what conditions we are able to get the reversible processes. So that particular idea you should have after the completion of this particular lecture. So thank you one and all for attending this particular lecture, and we will meet you in the next classroom discussion topic. Thank you.